now we're going to figure out how to find determinants. And, the first thing is, what is a determinant? And a determinant looks like this. This is the sign for determinant. So, what is this, and how do we figure it out, and what does it have to do with matrices? The determinant is really helpful in solving complex matrices and other problems. It's usually a big building block in complex equations. But in order to tackle that, we first have to figure out, how do we find one? So, here's our matrices, and we're looking for our determinant. How do we find it? We're going to multiply these two and put them here, and then subtract that from these two and put that here. So, 2 times 3 is 6, and 5 times 4 is 20. And 6 minus 20 is negative 14. So, negative 14 is our determinant. It's really simple. All you have to do is multiply these two buddies and these two buddies. And by the way, this is only for 2 by 2 equations. Solving 2 by 3 and finding the determinants for that, or 3 by 3s, are much trickier, and usually you just want to figure that out in your graphing calculator. So, what do? We multiply 3 by 2, so we get ourselves another lovely 6. We subtract that from 7 times 7, which is 49. And that gives us negative 43. And that is our determinant. So it's so simple. I hate myself. So it's so simple. And I mean it. It's so simple. Like, how simpler can you get with just a 2 by 2? Again, it is just, and here, let me write this out for you kiddos that like equations. It is A and D minus C and B. It's that simple. So determinants help with inverses. So how do we use determinants to find inverses? Well, there's another handy equation, and it is the inverse, which is represented by a to the negative 1, is equal to 1 over the determinant times d a negative c negative b. So you see how our normal matrices would be A, B, C, D, right? And this one is different because D and A are flopped, and B and C have turned negative. So this is how we find the inverse, because first off we have to get the determinant and put it here, and then we have to flip the equation around and multiply that by 1 over the determinant in order to get the inverse. So let's try it out with the previous problems we just did. I know it may look a little complicated, but it's really simple. Literally, all you do with scalar multiplication is you just multiply this with each number. It's that easy. It's that easy. So it's really easy. So this matrices would be 3, negative 14, negative 4, negative 14, negative 5 over negative 14, and 2 over negative 14. And don't forget to simplify. Which ones of these can we simplify? We could definitely simplify this one into 1 and negative 7. We can also simplify this one to be negative 2 over negative 7, which ultimately becomes 2/7. And this ultimately becomes 5/14. So see, it's just really, really easy to find the inverse. And the special thing about inverses is when you multiply your original So the original times its inverse gives you the identity matrix. Now let's just work out one more problem to make sure we know how to find the inverse. Let's try this one. So we already know that the determinant is negative 43. That goes over a 1. And then we have to do 2, 3, negative 7, negative 7. And then we just multiply it out. 2, negative 43, negative 7, negative 43, negative 7, negative 43, and 3 over negative 43. Very simple, very easy. And that gives us our inverse.